Good afternoon, ladies and gentlemen, and welcome to this webinar on the MasterKey Wind Analysis. My name is Martin O'Gara, and with me today answering your questions is my colleague Tommy White. As I say, today we're here to have a good look at the MasterKey Wind Analysis webinar. It is a training style webinar today, so it's hopefully going to get into the nitty-gritty of how we actually pull everything together to apply wind loading to our structures. First of all, just a quick look at what we're actually going to cover today. The MasterKey Wind Analysis is one module of the MasterSeries. So to that end, it can actually operate as a standalone module, but by all means, that's certainly not the full scope of what the wind analysis has to offer. On its own, it's used for establishing wind site pressures, and that's where it ends. But really where its real power and flexibility and comes into play is its integration with our modelling environment, our MasterSeries building design suite. So used in conjunction with the MasterFrame and our 3D model manager in particular, it comes together with those two programs to form the core of the trio of modelling programs of the building design suite. So with those programs, we can apply wind loading to really all manner and variety of shapes and sizes of buildings, with all variety of features. We'll be looking at how we deal with canopies and parapets and open-sided structures. I mention those specifically because those are new features to the 2011 version of MasterSeries. And we'll also be looking at obviously how we can view and validate those. Also new to the 2011 version of MasterSeries is the integration of the MasterKey Wind Analysis with the Masterport Plus, and that's really quite straightforward, but we'll be having a little look at that at the end. So I'm just going to exit that PowerPoint and let's get straight into to using the program. So today I'm not going to take any time generating structures. We're going to take a structure which has been generated and look at how we go through the process of actually applying wind loading to this structure. So if I come in to my directories, I have some projects here which already have some of which already have wind loading applied, and others of which don't have any wind loading applied. So just to take a quick look at a structure perhaps which does have some wind loading applied to it already, just to see the end goal of what we can actually achieve with what we're looking at here today. I suppose just rewinding just for a second, we did say we would look at the standalone version of this program first of all. Not that we're going to truly take any time on it, but from the designer suite, the MasterKey Wind Analysis is accessible as a standalone program, and very simply, if I were to open up an existing file here, its features are that you can select a site either on the map or by entering in a national grid reference or by entering in eastings and northings, and that locates your site and it communicates with the Breeze program in the background for establishing the actual wind site pressures. So we have different methods of doing that. We're working to the Eurocode here at the moment. Of course, we can come up to our design code and say, no, actually we want the British code, and we have different methods of arriving at the wind site pressure, whether it be the standard method or the directional method, and also options in other areas to, for example, use the UK directional factors, and we get nice little graphics here of the actual wind and how it would look varying through the different heights that we've specified and the different wind diagonals as well. So really there are lots of options here, which all of which are in line with the code of practice. It automatically picks up things like obstructions, and for the site, the distances to town, sea and country are all picked up from the Ordnance Survey data, as well as detailed topography information, although albeit in this case I've chosen to use site altitude only, whereas I really would like to use the full topography internal data from the detailed database of information. And really, after all this has gone through the mill and calculated, at the end of the day we are taking these Q values that we see here for the different heights above ground and for each of the different directions. Now that's the way in which it can be used on a standalone basis. However, we'll see really how that is much more powerful and intuitive when we integrate it with our frame building models. So we'll just come out of that. I'll take a look at how we can maybe set up default sites and enter user sites when we actually get into the frame building modeling aspect of it as well, because we'll be linking through to that exact same environment with our frame. So just taking a look, as I say, first of all, of what our integrated look at with the MasterKey Wind Analysis is all about. So here I have my master frame program, but also on top of master frame I have an additional module called the 3D Model Manager, which comes together to apply wind panels to the structure. So all the different colors here are all the different wind panels, so that's one of the jobs we'll be doing. We'll be setting up the wind panels. That's probably one of the most detailed things we're going to be looking at here today. But the 3D Model Manager and Master Frame on its own, without the MasterKey Wind Analysis, you could still do this, but you'd have the job of going around and entering in what the actual kilonewton per meter squared value of wind loading is for each of the different wind directions and all these different surfaces. So this is really where the MasterKey Wind Analysis comes in and says, no, you don't need to do that. We will look at the shape of the structure and the way all the panels come together to form the shape of your building, and we will figure out, in accordance with the wind directions that you have here, what the zoning is on the structure, and then in turn also what the coefficients of pressure are on each of those parts of the structure also for whatever wind directions you ask us to consider. You can also look at the actual zoning designations in accordance with the code as well. We'll be looking at all of this in greater detail, as well as looking at final panel pressures, because this has been linked to the wind to a particular site. It knows its dynamic wind pressure value for the site that it's at, and it can work out these Q values and apply them, of course, back to the members as distributed member loads. So those are all the things we're going to be looking at in detail here. That's just a brief summary of the main advantages the MasterKey Wind Analysis has to offer you there. So let's look at how we can actually do this in detail. So let's open up another file that we have here, and I have a little simple structure which will demonstrate the processes that one would work through to achieve the type of wind of application that you've just seen there. So let's go into the editing part of the master frame, and from the 3D Model Manager menu we have its own separate wind loading flyout menu. Now this is a nice little set of functions or menu items that we'll work through here in a logical sequence from top to bottom to complete the wind loading application on our structure. One of the first things we want to look at here is something called wind diagonals. Now those of you familiar with the BS 6399 will know we talk about diagonal values, small a values, which form something called a size reduction factor, a CA reduction factor, which basically says for certain members that carry larger areas of wind, they can have a diagonal value applied to them, which basically reduces the amount of wind pressure that they have to be designed for. And we allow for that in the program by allowing you to choose those members and assigning the actual wind pressure diagonal value to them. So we'll go into that. Now this is a message here telling me that I need to turn on the main area loading options of the 3D Model Manager before I can apply the wind. So that's the main setting, to turn that on, so that's fine. And we'll come back to this menu item and back to wind diagonals. Now the setting up of the wind diagonals, I suppose I should say first of all, is optional. If you don't set them up, you will get a more conservative answer, because all of your members in the structure will default to a wind diagonal 5, which is a CA reduction factor of 1, so therefore you don't get any size reduction factors. But taking, for example, bracing members such as these ones here, we might have wind loading applied to this face of the structure, horizontally spanning onto these columns, and of course the columns will be locally loaded with wind. They won't have any size reduction factors on them. There, if you wanted to be very strict about it, their diagonal value would be the diagonal of the panel in which the wind loading comes from. But taking these members, for example, they're carrying wind really from this whole facade of the structure. So the wind diagonal of these bracing members here, the surface area of wind that they carry is this surface, therefore their wind diagonal is the diagonal of this surface here. So for example, if I were to look at the Z coordinate, it's a length of 56 meters, so we might just guesstimate that we've got a wind diagonal there of 60 meters on those members, and we'll go into something called apply mode, and we'll just pick up those few members there to do that. Now I'm not going to go around this building setting up all the wind diagonal members, obviously I don't have time to do that here today. I will just pick up these two on the other side, obviously, because that applies to them as well, and keep going. Now you might turn around and say, well actually what about these diagonal members? Well yes, they would also have a wind diagonal which might be picked up from this face, and you might turn around and say, well I wanted another wind diagonal of, I'm going to guess and say 30 meters this time, and then start picking those members up, and that's absolutely fine, and you can do that. However, we would advise that it's not always wise to go and set up the wind diagonals to say that you've got, let's say, another one of 35 and another one of 40 for lots of different members, because the downside to that is that for every wind diagonal that you tell the structure that it must consider, we get another whole set of wind loading cases that have to be analysed to cover that application of Q value. So you do get penalised on that score. So I'm just going to delete this case, and I'll just go with my my case of where I've got a wind diagonal of 60 for those members, and sorry, that's the default value I'm typing in there. We leave the default value at 5. The current wind diagonal is 60. I really need to pay more attention. So that's absolutely fine. We're getting those on there, and those members, when we come through to our design phase, would actually be designed for a reduced Q value in accordance with this diagonal value going through to CA reduction value. So just a brief explanation of what that's all about. Next, flying through this now, we come to consider what wind directions we would like to consider on the structure. And quite simply in this structure I would just like to consider my 4 orthogonal wind directions, and those can quickly be applied by double clicking twice. So 2 double clicks to fill in the standard 0, 90, 180, 270. Of course you can go and pull in 45 and 22.5, whatever wind directions you would like to consider on your structure for its given shape. You get up to 8 different wind directions that you can consider there. Also on this structure, I'm going to say that I would just like to consider the standard internal pressure and internal suction coefficients, 0.2s and 0.3s. You enter those as their absolute value. The program obviously distinguishes between pressure and suction and applies them with the appropriate sign. Because I'm actually linking through to the MasterKey Wind Analysis, I do need to say yes, I will use the MasterKey Wind Analysis method for determining the wind side pressure value. I'm going to use the directional method in the 6399 for establishing that. And because I'm using the directional method and also using UK directional factors, that means my wind pressure is not going to be the same value in each direction. So the orientation of the structure on its actual physical site is important. So you can enter, obviously I can enter 15 degrees here, and we can see the orientation from the frames. That sets the angle between the global Z direction and magnetic north, as you can see here on the little result axis symbol. If you don't know your orientation of your building and you really just want to apply the same Q value throughout, then you can do two things. You can switch back to the standard method, which uses the same, it doesn't take into account all the different variations and town, sea and country throughout. It uses the same value throughout the whole site, but then you also must go back to using the standard directional factor of 1, so you don't get a different value of wind throughout your structure. But I do know my factors and my building location and orientation, so I'm going to set that as such. Another very important number here, which people maybe might often overlook, is the dynamic augmentation factor. Now that's set to quite a high default value of 0.25. And when we look up the table in the 6399 to establish what its dynamic augmentation factor is for the type of structure that we have and the type of cladding it is on it, and it's its H over B ratios and such, we probably will find for a structure like that that number will come down. So a quick look up in a table in the code might even yield that number can come down to 0.05. So immediately we've taken 20% off the value of wind there. So that's quite important to pay attention to that and arrive at a suitable value. If we were to come back to this menu and work our way down through it, the next item would be wind loading cases, but in actual fact it would just bring me to the same area here. So having established this data of directions, pressure coefficients, and also actually the wind diagonals previously, I have all the information to hand now to allow the program to automatically set up all the wind loading combinations for my structure. So I'm going to say I wanted a dead plus live, and the tooltip tells me it's going to be minimum dead plus 1.4 wind. Sorry, dead plus wind that was. I'm not going to do the factor dead plus wind. I will do the factor dead plus live plus wind, and let's also set up the serviceability cases to go along with those. So that has actually just set up me 4 additional cases, but now I'm going to say I want to propagate those 4 cases into a total of 64 wind loading cases. So I will do that, and if I were to come to my actual load combinations, which are just up here, I can see all the different permutations that has generated for me. So I can see here I've got dead plus wind with a wind diagonal of 5, just with external wind only. But as I would come down through these cases, we can see I've got additional cases which is exactly the same, but this time with a wind diagonal of 60. Now what we'll find when we go through to the design, that this particular case, it's only the wind cases that have a diagonal of 60, hence a lower value of Q, which will be used to design these diagonal members here, whereas all the other members would select from the default wind diagonal of 5 because they don't belong to any particular wind diagonal group setting. Now going down through this here, we see obviously all the ones that we'd set up, and obviously the repeats are for the 2 different wind diagonal values. But then we start to come across not W1 but something called P1, which again is dead plus wind with that factor, wind diagonal of 5, but this time with an internal pressure along with the external pressure coefficient, which will be evaluated as we'll see later. And then obviously all the permutations and combinations on that, and then we come to the same thing with internal suction. So these 3 buttons have been selected appropriately in the automatic wind loading case generation. So if you're generating your own wind loading cases, you do need to pay attention to what wind diagonal you've set it to, and also whether you're including internal pressure or suction or not at all. So let's exit from that area and proceed down through our menu. And next thing we're coming to is our MasterKey Wind site data. And this is us simply back to the same location or the same interface that we looked at a moment ago in the standalone area. So of course we can pick on the site, we can enter our own national grid reference as we mentioned just a moment ago, and obviously that is picking up the obstruction data, distances to town, sea and country. As we can see, if I were to pick somewhere inside a town, you can see in this little symbol here all the different fetches and what the distances are to the edge of town, the edge of the country, and then obviously on to sea. The topography, I'm using the internal data there, I'm happy with that. And I'm actually on Eurocode here, so the overall setting of this file from the analysis end must be on the Eurocode, which is absolutely fine. I will have a little note on that later on about what we're doing to the Eurocode and some of the caveats on that. But for now, let's be happy to stick with the Eurocode. And really, at the end of the day, apart from picking your site, there's really not an awful lot more you generally would need to do here. And as we come down through again all the different heights of the structure that have come through, we come to a nice little summary at the bottom, which gives us for our 2 diagonal values and for our 4 wind directions that we asked to consider. For all the different heights of the structure, we see what the actual Q values are, and these are the values which will feed back through to be combined with our coefficients of pressure, which will determine to arrive at the actual pressure values are, which will be transferred back to the members. I should note that albeit we are giving you the different Q values for all the different heights of the structure, it's not a case that for members at 3 meters, 3.181 meters high, we're going to use this Q value, because of course there are rules in the code with regard to how you can vary Q over the height of the structure. And obviously you've got your rules with regard to, say for a tall structure, you've got a constant zone of wind equal to the crosswind breadth at the bottom, another constant zone at the top, and linearly varying in between. We adhere to all those rules. We look at the crosswind breadth with regard to the height of the structure, and more than likely for a structure like this, which isn't very tall, I would imagine we'll be using the Q value from the top of the structure for the entire structure through the height of it, so we'll probably not notice any variation in Q through the height of the structure in this instance, but that is being considered for you. Now in this area as well, if we wanted to deviate from what is a UK region, we can, of course, there are various things that we can do. Obviously because of our location here and our favour towards our own clients and people on this little island of ours here, we have sat down and taken some time to enter in additional sites which are outside of the Breve program of the UK wind site data. So for example, we've got a generic site in Dublin that we have put together for you and we've stored internally, which we simply have sat down and said, well, this is a default site, and we have entered in some fairly default obstruction values, and then simply here we have entered distances to town, sea and country. So for example, for the 0 degrees, which is the red line here, we've got 4 kilometers to the edge of town, 55 kilometers from our site to the edge of country, and then you generally end up with a 200 value to give you a large value of C beyond that point. But of course you could actually come back from C back to country, but we're just going for C for an infinite distance there, which doesn't affect anything else. So that's all those values inserted. Now naturally you can imagine if you wanted to generate your own site, you can do that by simply saying, well, I want to set a new default site. So this is my own new default site, which can be anywhere in the world, and simply you go through and fill out that data of your distances to town, sea and country for all the different wind directions, and you can of course enter topography data, which is actually quite difficult. By and large, a lot of the time people might turn around and say, well, actually I just work to site altitude only, which may have its aspects of being non-conservative, because obviously sometimes topography can actually increase the way the wind is being applied to increase your actual final wind side pressure value. So just to bear that in mind. But you do have the different options there. But generally they'd be either the internal data or the site altitude data that we would see people using. There are other options as well. Now what you will find if you wanted to know any more of the detail on any of these options is you're better off referring to the actual Breve help manual. When MasterSeries is installed, the Breve application is also installed, so you'll find that somewhere in your menus. When you go to it, you can go to the Breve help manual and it will tell you what the definitions are for user-defined site and the external SHF file. So back to our model. The main job we've got left to do, and in fact the final job in this list of tasks here, is the generation of the wind panels. And you'll find this is one of the most involved tasks of applying wind to a structure. Now in the release of the MasterSeries 2010 version, we did make some really nice changes to the way in which panels were generated. Previous to the 2010 version, panels were all generated based on a member selection, so you selected all the members to create wind panels, and we're going to talk about the difference between member mode and panel mode, and we also have some other modes called fast selection of panel modes, and then an automatic all option which generates all the wind panels enveloping an entire structure. But let's just have a little look at what we mean when we say wind panels. What we're looking at here is the settings of one particular wind surface. Now a wind surface is a collection of wind panels. that form a planar surface. So that's the first important thing to note, that a wind surface is a planar surface. So for example, in this structure we might have a wind surface on the edge here, we might have another wind surface in this face here, and going around the structure building up wind surfaces as we go. And then actually on our roof here, because of the curved aspect of the roof, we're going to have different facets of wind surfaces building up the whole roof application of wind. So this is actually one group, and we can add further groups. So we've got one default group here, and we can add more groups. So we'll use this first group for our first wind surface. So we've got to be in this add remove mode to be able to add items to this group. And I'm in a panel mode, so I'm in a panel selection mode, which is why when I hover my mouse around I get the selection of panels. So as I click, I can see naturally the panels being selected, and of course I can also cross window to select groups of panels also. So that's really quite easy. That's one wind panel generated there already. Just a few features of this wind panel, looking at it. First of all, we've got wind arrows on the outside of the structure, which really must always be pointing to the outside of the structure, and the program almost always certainly sets that as the default, in that it will detect what's the outside of the structure and what's the inside of the structure and have that such. If that wasn't the case, you could swap those arrows around to the right side, but the default will generally be fine in 95% of the time. What we can also do there is look at the span direction of the wind loading on this here. So we're dealing with a one directional span, and at the minute it's spanning horizontally, but we can also span it vertically, or indeed changing to two-way spanning. Back to one-way spanning, we also have a third option for spanning the shortest direction. So you can see actually this little panel here, if we were to zoom down into it a bit, has decided no, its actual shortest direction is a horizontal span instead of a vertical span. Naturally that's not the sort of variation that you would do, but there are times when this setting is indeed quite convenient. So we'll just put that back to vertical spanning. Now I want to continue to move around the structure to generate more wind panels. So as I can see, I might be tempted to come along now here and click over here and start generating more wind panels along this facade here. The program won't allow me to do that in this instance because I'm still working with this one wind facade here, and I can't actually add anything to this facade which isn't on the same plane as it. So that's a little protection for you, in that you can't inadvertently add a panel or a member that is outside of that plane. Even though I'm clicking here, nothing is actually being added to this side. So let's add a new wind surface. So just clicking on add new here, I can see I now get item 2 of 2, and I'd like to continue to add wind panels to this facade here. Now, the first thing I notice is normally when I hover over a panel I can see it highlighted, so I know when I click I'm going to select that panel. But now when I come to my front elevation, I can see actually that it's not highlighting those panels, and that's because they're not actually proper panels. They are open-sided panels, and the program doesn't recognize them as such as proper real panels. Now, one of the ways in which we could get around that is by switching from panel mode into member mode. And in member mode, if I were to select the members of the panel, because it's intelligent in a sense in that it will detect that this is an open-sided panel, and we have an option here to automatically close open-sided panels based on the selection of members. And in this instance, because it's spanning vertically into the ground and there's no member there, we only get half the panel, obviously with the other half disappearing into the ground. So basically I could continue to select members, and of course I can window members as well. So if I were to put my structure on an appropriate view and draw a nice little window up along here like this, that gets me all the rest of those members as well. And I've actually picked up the bracing members there as well, so I need to knock those out to get what I want there. And of course I've got a missing column in the corner here, which we'll also deal with in a moment or two. But in actual fact, what we would highly recommend, instead of going into this member select mode and doing that type of thing, is really to make proper panels out of these types of members, or types of panels, by inserting what we call a dummy member all the way along the base of this structure. And indeed that's what we've done along many of the other edges right the way around the other parts of the structure. which is the reason why we were able to select the panels on this facade earlier, because they were already closed off with this dummy member. A dummy member is really a non-structural member which doesn't have any contribution to the analysis. So let's do that. Let's add some dummy members to this front facade. And on the subject of these dummy members, what we also would have a need for is a column in this corner location here, so we can frame out the wind loading in this area, and the wind loading might continue to span vertically back to the members, and the dummy member wouldn't actually attract any wind loading to itself. I suppose it's worthwhile noting, even if you do apply wind loading, let's say horizontally spanning, and it did come onto this dummy column member which we're about to slot in, the load would still be transmitted back to the structure, so it's not like you would lose the wind loading. Before we add these dummy members, I also have a need for a similar type of situation which would often arise. If I were to put this in a 3D profile, we'll see what we're talking about here. And we have a column, a member coming up, and of course when we get to this internal corner here, we have an offset column position, which means again we've got an open-sided panel which will really behave much better with us if we were to insert a dummy column there, closing that off. So let's do that. So we'll just come into my add define new members here, and in this 3D model manager define new member functionality, we have the option to specify that the member is indeed a dummy member at the time of its generation, so I don't need to go in and specify it as a separate attribute at a later stage. So we'll just snap in the dummy member coming all the way down the side here, going from node to node. Of course I could speed that process up by doing what's called a polyline snap, so we could just go from one node to the next, but I will just continue on that. Now when I get to this location, I don't actually have a node out in this corner, so this is where I'm going to use a handy little facility. So click on the first node, and then I'll use my track member facility, tracking on this member, to automatically extend that tracking point out to this location, and I'll continue with that around there. In actual fact, I'll just pop that member up to that node point in that location, and of course I've got my corner column that I can slot in up here now too. So if I go back to my wind panels, we'll see that they will indeed behave in a much better fashion for me. So that's something we would recommend for the bottoms of your columns when you're applying wind loading, is to close them off nice and neatly with those dummy members. So I'm on my panel 1 of 1. I'll go to apply mode and I'll just actually apply that to those, and again adding my second panel, which I previously deleted, and now I'm able to easily pick up those members like that. Of course I can continue working around here, adding another panel and coming along this way. Of course I can cross window, but I can continue to do that. Now this might be an interesting facade to discuss one of the aspects of the way in which we sometimes might configure the splitting up of the wind surfaces. I can of course come in here and specify everything here as one entire wind surface. However, there are instances where you might say, well, that's fine, I'm going to continue to do that, but this inset story feature of this elevation and making it one entire wind surface will actually affect the way the wind zoning will be carried out. What we're talking about here is if we would consider the case of wind blowing parallel to the plane of this surface in this kind of direction. Naturally, we know to the code, the 6399, that we get higher wind pressures on the leading wind edges, so we might start off with a zone A going to a zone B, maybe all the way back to a zone D at this side. With this surface as one entire surface, the zone A will start at the leading wind edge of the surface and go all the way back to a zone D. So when we get to here, actually we might be in a zone B or something like that, and this would be a zone B throughout the entire height. Whereas in actual fact we might like to start off with the new leading wind edge for this portion, going from zone A all the way back to zone maybe B or however far it might extend. So to that end, we would recommend that you would split up these types of panels so that they are horizontally banded, so you can have that facility of having a different leading wind edge. So we've now got two panels. If I can draw all the panels down here that we're doing so far, we can see this is a separate panel from this, meaning that this can have a different leading wind edge and really it start its own zoning from this location, as opposed to taking the zoning starting from the overall panel location. So that's something to bear in mind also. Now that zoning, that banding, I would continue actually around, so that the splitting up would continue around the other side of the structure and all the way around the entire structure, so that this surface would be separate from this surface. Where you have that inset story type of arrangement, we would recommend that you split your panels up in that fashion. Now I want to talk about as well, if I would come onto this surface, so I'm not going to continue with this horizontal banding. I'm going to simply continue with this as one whole surface, because I'm going to talk about another feature and aspect of something called panel combinations. So I want to add another new fifth surface here, and this time I'm going to just simply window a set of surfaces to speed my job up a bit, so that I can do this a little bit more quickly. So windowing those, and if I had a need in this instance for these surfaces to be vertically spanning, but then coming along to some of these other surfaces, I might want them to be two-way spanning, then that's a case whereby I would have to specify this, let's say this end panel, to be a separate surface. So I'd have one set of surfaces here, and I'm just going to, you can probably see that we have a little issue here, which I suppose we better address before we continue, as it affects what we're doing here and now. But the these panels that we're looking at here, we notice that they're not nice and rectangular in the way that some of the other panels are, and indeed that's because we didn't have the same problem around here. Obviously the splitting up of these panels is occurring because of the bracing members, but these bracing members really we don't want to be part of the panel definition, and that's really just something else to draw your attention to. If we go back up to our Model Manager menu into bracing members, we can see that these other members that didn't cause us the problem were all defined as bracing members, which has been done by the user previously, but these members have been missed as bracing members, so they've adversely split up the panel in a way that we don't want them to. So we need to add those in as bracing members, so that they are ignored basically from the overall panel geometry, and allow the wind loading to span over them as if they weren't there. So let's go back to our wind panel generation, and if I come back to my surface 5, I can now see that I can add those in without those bracing members affecting the panel generation. Okay, back to our concept of panel combinations. So I have everything vertically spanning, and as I say, I want this end bay to be two-way spanning. So let's add another new surface here on that. We'll set it to be two-way spanning, and we'll slot that in as two-way spanning. Now that's absolutely fine. I've got two sets of panels there if I draw them all. One vertically, one two-way spanning. And again, where that might have an effect where we don't desire it is again with regard to the wind zoning, and considering, for example, if you'd wind blowing in this direction parallel to this surface, again you've got your leading wind edges from the start of the panel that's been defined. Now that might mean that we have a leading wind edge starting here, so it might have an AAB and then it will start again from an AAB CD. To avoid that, we will would like to combine these two panels so that they are considered as one group of panels in terms of the zoning and where the zoning is actually measured from. So with this panel on the end, I'm going to say that I want to select panels to combine with. So in a panel combine mode, that stays on. I click on this surface and it's now combining those two. Now you can also do that if you can imagine that this was on a slight curve and we had lots of wind surfaces set up as different facets. We might have 10 different wind surfaces set up because of the curve, each being on a different facet. Again, you could do that so that you would make all the panels part of one wind zone in terms of the distribution of the zoning throughout the length of the wind surface. But that's all we need to do there, and I'll need to turn off that panel mode. And both panels that are part of the same combination group are joined together because of the draw all, and if you take that draw all off, they won't show them together. But it's convenient to keep that on so you can actually see what's happening here. Now you may have noticed as we've been going, the program has been labeling each of these surfaces with appropriate titles. Now those are basically automatically titled and do have a relevance, so we really generally don't need to touch that or specify anything otherwise. So we've gone around the entire wall system of the structure. Now I've talked about the panel mode, we've looked at memory mode, but now I want to also look at something called fast selection mode. So in fast selection mode, it allows me to, I'm not even telling it to add a new surface or anything this time, but it automatically detects all the panels that are create one entire wind surface. So if we can maybe rotate ourselves around a little bit to see that more clearly. So now if I click here, for example, it's detected that all of those surfaces are part of one planar facade and has picked that up as such. So with this auto select mode, we can quickly, you can imagine we could have quickly just clicked on this one surface to define it, as opposed to having to be in an individual panel mode where we have to pick on the panels or window them to define them. So we can do that, and that's our roof panels defined. You might have wondered why, for example, this little surface here wasn't picked up along with its surface that it was attached to. However, we can see that the main reason for that is because we've got this projecting as a canopy, and the program does identify canopy surfaces as separate from the main surfaces, which have wind loading on the outside and the other side is internal. So when I click on this, it does actually automatically check the canopy box and to say that it is a canopy surface, so that will split that up. And the same thing goes for this one down here. You might have expected it to be part of this surface, but it's kept separate with the canopy option checked to set it as a canopy as such. And we'll be taking a look at a structure later on which shows a bit more about canopies, and we'll be discussing that in more detail. So really we've got the entire wind loading in this structure, well, apart from this surface here, which we can complete in the fast selection mode, and also these other two wall surfaces as well. And really that concludes the entire application of wind loading in this structure. Now, of course, I think I actually set myself to two-way spanning at some point and didn't set it back, so you can go through those surfaces and set them obviously to be whatever span direction you want them to be for all the different groups. Now the final mode that we have here is automatic generation for all surfaces, which is really envelopes the entire structure. So if we're to bring ourselves back to a situation where we don't have anything, so let's undo all our hard work here, deleting all of those panels. The first thing you might try when you come into wind load a structure, obviously we'd recommend that you look at scenarios of where you need to input your dummy members and close off panels, but where you feel you've done that type of preparation, coming into this area, if we were to click the automatic all, that will go around all the exterior facades in the structure and automatically pick those up. Now it doesn't decide to do any horizontal banding, so if you do want to horizontally band the surfaces as we've discussed, that's something you can go in and edit them and do that type of thing. So, but it's done pretty much the same job that we spent 5 or 10 minutes doing manually just a few moments ago, so that can save you quite a bit of time, particularly for complicated geometries. So we take the draw all off. If we did want to come back, so I'm in a search mode here whereby I'm clicking on the panel to go to that panel in the list of panels. So it is important that you know which mode you're in, where you're in apply mode or search mode. Search mode is safe mode, so you're not actually changing anything. But really, if I wanted to change that panel, I now go to apply mode and I could take these surfaces off. If I were to come in here, and I'm actually in the wrong mode, I need to be in panel mode, so that's another thing to keep your eye on. So taking those off and then adding in another new surface and creating those back in again as a separate surface. So that's how I've split that surface up to make it now two surfaces instead of one. It's worthwhile having another closer look at a particular wind surface and some of the options that are available to us here. We've been looking at span direction. However, there are other further options, such as you can obviously you've got one directional spanning, whether it's horizontal or vertical, but you can also pick a member so that the span direction is parallel to a particular member. So if I were to click on that and then click on this member, for example, I can see now the span is actually running parallel to this particular member that I have selected here. But obviously that's not the sort of thing that we'd like to do here. It actually fills in the angle in accordance with the member that you've selected. So you can specify an angle there of 30 degrees or whatever the case is to rotate that around. The auto set can sometimes basically automatically detect what the best span direction is for the entire surface. So obviously in this case it's set it to 0, being the shortest for horizontally spanning. But we'll just change that back to vertically spanning. Other aspects of a particular wind surface would be the option to input your own coefficients of pressure. We don't need to do that generally, because the program, the MasterKey Wind Analysis, is about to do this job for us. It's about to assess the shape of the structure and assess the CPE values for all the surfaces and all the different wind directions. But if we didn't like some of the assumptions the program was making, or we wanted to override that, we can come in here, and for wind direction 1 that we'd specified previously, we can enter our own CPE value in there. Furthermore than maybe entering a specific CPE value, if we were looking at the zoning of a wall, for example, we might look at the zoning of this wall and see that it is zone A, B, C, D. But if we just want it to be zone A, B, or just zone CD, we can type that in there. We can type in A, B, or override it with CD, and it will work with that zoning designation and the appropriate CPE values from the tables in accordance with those zones. A couple of other items we have there are funneling. If you can imagine, if we had another structure which was parallel to this structure out in this direction with a wall opposite this particular wall, then we'd have a case where we might have some funneling effects, and we can enter in an appropriate funneling ratio. There's a technical note on how that's calculated, or how you arrive at that figure for the MasterSeries program as well. Finally, to look at some of our roof surfaces here, where this plus minus setting might be relevant. Those of you familiar with the 6399 will know there are instances where there are, particularly for sloping surfaces of the higher angles, you have cases whereby you have both positive and negative values given in the tables of code for the coefficients of pressure. Now by default the MasterSeries is always going to go for the negative, which is the suction. However, if you want to consider also the positive, then you can force it to do that by saying, if you wanted wind direction 1 to consider the positive option of wind pressure, you can enter in the plus there in that instance. Where this is used really in reality would be that perhaps you might allow wind direction 1 to continue with the default negative suction, and then we've used wind directions 1, 2, 3 and 4. We might then come and use wind direction 5 with the actual same direction of wind as wind direction 1, but this time tell it we want to consider the positive case. So therefore we've got a separate load group now which considers the positive case, with the W1 considering the negative case, and that's how we handle that. And then obviously you can build up additional wind loading cases, or the program will do that for you automatically. When you give it a wind direction, it will add that to the combinations that we generated previously automatically. So with all of those settings in place, and let's close down from this area and have a look at how all of those things come together to give us the wind. So we're up here in our top toolbar, we're saying draw all selected loads, and we're telling it to draw all the wind loading. We've also chosen the option to draw all wind loads per intensity, and then down here we have the ability to look at particular wind directions. So for wind direction 1, let's have a look at what we get here. So we've got simply color coding going on here, which represents greens for suction, so heavier shades of green for heavier suction, and then also we have yellows and oranges for the pressure values that we see there. So I can view my coefficients of pressure. So I can see my positive values in this region and my negative values around in this region. So I can see quite clearly my zone A, B going probably to CD zone down in this end. But if I do want to actually see the zoning designations, I can click on my W wind zoning label to actually see those, so I can see how it's working out for me there. Now the program weights the zones, so we can see I've got a zone A, B here, which means this panel is partially in zone A, partially in zone B, and it will calculate itself in terms of how much of the panel is in which zone, and weight the overall coefficient of pressure in the panel appropriately. Of course we can view the final panel pressures as well, which are indeed the in this case what we're looking at for overall wind is including the 0.85 reduction factor and the dynamic augmentation factor there of CR. We are looking at the Q values times the CPE values, so that actually takes the Q value into play there, and you can see there's a constant Q value throughout the height, with these values not changing over the height of the structure as we'd mentioned previously. Of course then we can look at different wind directions and what happens in that scenario, and turning our way around here, and of course you're getting zero values along here because I think we told it to ignore the wind loading coming on to the dummy members around that location, and coming in all the different wind directions. Furthermore than the actual overall drawing of the wind, we can also look at the detail of the wind loading application in what the actual values are that are on the members. We can do that in two ways. We can look at an overall wind loading or loading diagram. Now we're looking at quite a messy space of all the loads in the structure here, so we're going to say we'll just want to look at a particular load case. So for example the W1 wind loads, let's have a look at those, and let's change the scale of the distributed loads here, and we can see what we have here. We simply have obviously one-way spanning in this direction, which maybe isn't what we want. We probably want one-way spanning in the other direction, parallel with the x-axis, but that's what was set up here, and we can see everything coming through there on that basis. So we can see the actual kilonewton per meter value coming into play there, and we can obviously easily validate that and verify that that is the sort of figure that we would expect there. We're actually looking at that's W1, but of course we can look at external wind with internal pressure, which is the P1. So internal pressure obviously is reducing those external values, whereas if we look at that with internal suction, we can see those values actually increasing because we've got external pressure with an internal suction giving you overall net increase, which obviously has the opposite effect, where we've got suction on the outside and then obviously suction on the inside, cancelling certain aspects out. And we can actually go a little bit deeper than the overall looking at the wind and look at the detail of the wind loads arrived at on a particular member by looking at the member information from the top toolbar here. So clicking on a member will list all of the loads that have been generated on that member. We have here a list of wind loads, both external wind, pressure and suction for all the different directions. And I suppose one of the things we notice here is that we're not actually, albeit our dead and live loads are in kilonewtons per meter, but our wind loads are listed as coefficient per meter as the actual unit we have here. Now that's the coefficient as being the coefficient, the CPE value combined with perhaps any internal pressure or suction per meter on the member. So that's not actually a load. That has to be multiplied by, in some cases, the Q value, maybe the 0.85 reduction value, and also maybe the 1 plus CR dynamic augmentation value to arrive at the final wind load on the member. The reason why these are given like this is because the actual Q value can vary from one wind loading case to the next because of wind diagonals. So to that end, if we were to list all the values for all the different cases, you would end up with quite a range of values. So those are multiplied at analysis time by their appropriate Q values, dynamic site pressure values, and any other factors that might need to be employed there. So just to bring that to your attention. Okay, we're going to leave this structure now, and we're going to have a look at some of the other aspects and features of the MasterKey Wind Analysis on the more advanced side. The 2011 version saw the introduction of the automatic assessment of wind loading on canopies and parapets, freestanding canopies and open-sided structures. So we're going to take a few minutes to look at some structures with those types of attributes. Now we're to look at this structure here for canopies and parapets, and the generation of the wind loading on this structure really is no different from what's already been done, or what we did just now in the structure that we looked at. So one can click on the auto generate all, and it would do a pretty good job of generating all of the surfaces on the structure, and of course we can make the manual changes like we have just done. So really what I'd really like to do is just to investigate the actual values of wind coming onto this structure. So I'm looking at wind direction 1. I want to look at the coefficients of pressure. So let's zoom right down in here, and I can see for this wind direction 1, let's remind ourselves, so this is wind direction 1 blowing onto this wall, creating a positive pressure, suction down the face. And with this particular type of canopy, the code classifies different canopies. You have canopies which are projections of the roof, which is what we're dealing with here. And in that case, it tells you that you take the coefficient of pressure of the upper surface as if it were a normal roof. So this is where, for example, 1.58 is coming from, or 1.568 is coming from. But then on the underside, you take the positive pressure of the wall and apply that to the underside of the canopy. Hence the reason why we're getting the minus 0.683. So a suction on the top with a pressure underneath, giving us an overall increased suction value going in the upwards direction on that canopy. Of course we can see that applying there, but as we turn the corner that dissipates because really the wind isn't blowing directly onto the wall surface, and also it changes from positive to pressure to suction values, which obviously we avoid the case whereby we would cancel out the suction above with the suction below, so that you're always looking at the worst case scenario there. If we were to look at, for example, wind direction 3 or 4 or 5, now this side is the case where we're getting our upper roof value, with the 0.623 being the pressure value from the wall below. So that's all coming into play there. We can also see the wind loading on the canopy, or sorry, the parapet coming into play there. So that's the canopies or parapets are really just a special case of a wall, and the code covers them quite clearly, and we deal with that. The code does deal with wall attached canopies different from roof overhang canopies. In fact, I should say the code excludes those canopies from what it deals with there, and refers to separate documentation for how one arrives at coefficients of pressure, and we're using that publication referenced in the code to arrive at these values. And we can see, if I come back to an appropriate wind direction, which is like this, we can see we're getting a similar scenario where we're getting an upper surface pressure with the lower surface pressure being deducted from that, which is equal to the pressure we get from the wall below. There are different rules in that publication with regard to the height of the canopy on the wall. Whether it's more than halfway up, it's dealt with differently again, and we're adhering to all of those rules. Let's have a look at another example of a different style of canopy. And it's the case of an open-sided structure. Now, with this structure, its setup of surfaces again is no different from what we would have set up previously in the first building that we looked at. Let's have a quick look at the wind panels that have been generated there. I'll just switch that back to this mode. So we have a look here. Of course, we can just see simply that this here this roof surface has been defined as a canopy. The actual wall surface underneath it, that is simply again an open-sided surface, But because it's not a parapet, we don't actually check the box to say wind on both sides. So for vertical surface where wind is on both sides, you only check this box where it is actually a physical parapet. In this case, it's a surface which supports the canopy, and it will receive its own internal pressure because of its interaction with the actual canopy. So those are the settings of the panels there. So let's have a look at how the program interprets those and arrives at the coefficients of pressure. So displaying all of those, color coded per intensity, and let's have a look at wind direction 1. So for wind direction 1, basically we haven't told the program that this is an open-sided structure as opposed to a roof projected canopy. The code tells us that where a canopy changes from a canopy to an open-sided structure is all to do with the projection of the canopy. So if the projection of the canopy is greater than the crosswind breadth divided by 10, then the program automatically takes it as an open-sided structure. In fact, if we look at the zoning designation, and where we detect something as an open-sided canopy, we will put an underscore OS open-sided against that in the zoning designation. So if you don't see that, then you know the program's basically assumed it to be a standard canopy, whereas in this case it said no, you're actually too large a projection, you're an open-sided structure. So that's useful to be able to actually see that classification taking place. But furthermore, in this roof surface, the code obviously has rules with regard to open-sided structures. Again, you take the standard coefficient of pressure on the roof, but then for the internal pressure coefficient, whereas if this were a wall overhang, you would take this 0.82 and use that. But we see here we're not getting 0.82, we're getting 0.77, and that comes from a little table in the code which really shows us, for example, for canopy surfaces that are supported or on one side, or open-sided structures which are open on one side or two sides or three sides. So obviously here what the program will do is take this surface, go around all the edges of it, and know that on this edge it's got a wall surface underneath. Also when it comes to this edge, we'll see that it has a wall surface as well, connected along a significant proportion of it. So it's going to look at this and say two sides are supported and use the appropriate coefficient of pressure from there. And as we come around or different directions, we can see then, because we've got a shelter in this case, it's actually going to a positive coefficient of pressure internally there, and then obviously in this direction again, because it's we have a positive internal pressure coefficient there also. Well, actually I should say a positive value, but it's actually an internal suction which combines with the external suction to actually, so you've got external suction with internal suction, meaning that value is actually reducing down to 0.36 or minus 0.36, and back to this direction where we've got the positive internal pressure value producing an overall increased suction on the outside of the surface. So that's how the program is dealing with those open-sided structures. If I were to take the case whereby I were to take this surface and split it up, such as this would be a separate surface from this main surface here, then this surface on the outside would not see itself as an open-sided canopy, because it wouldn't see any walls supporting it. It looks around all its edges and sees no walls, and therefore would classify itself as a freestanding canopy and take its coefficient of pressure from that end of the table. Now that might be fine, however in certain cases where the wind comes in this direction, we might want to influence that with something called a blockage ratio. So let's have a look at a proper case of where we've got a freestanding canopy and have a look at what we mean by that. So for our freestanding canopy, we quite simply have two surfaces here, and for those surfaces basically it's going to look at a surface, not see any wall connected to it whatsoever, and therefore decide that it is a freestanding canopy. And again, if we put on our zoning designations, so let's look at a particular wind direction and put on our zoning designations, we have something called a dual-pitched freestanding canopy as the zoning designation there, DPFSC, dual-pitched freestanding canopy. So again, there's an appropriate table in the code for that type of surface. The one more thing to note on the freestanding canopies, which we just mentioned a moment ago, say no to that, and back into the wind panel generation, is in the code we have an option for freestanding canopies to specify a blockage ratio. So we do give you the facility to specify that blockage ratio for that freestanding canopy at this end. So for example, if I were to put in a 0.85, really what we're saying is about for 85% the height of this column on the downwind slope. So for wind direction 1 coming in this direction, the blockage ratio for the downwind end of the canopy is thus, so therefore I would expect to get an increased value of internal pressure naturally, creating an overall net increase in internal overall suction on the outside. So we can see how that comes into play by looking at the values, and it would have been 0.79 previously, now it's 0.114. In actual fact, that blockage ratio probably would need to have been specified on this surface as well as this surface, as they are connected, and the blockage would affect this surface equally as much as this surface. So those are some of the aspects and some of the new aspects that are in the 2011 with regard to roof overhang canopies, wall connected canopies, open-sided structures, freestanding canopies, and also parapets. All of those things new to the MasterSeries 2011. We did say in the beginning we would also have a final look at the Masterport Plus, because the 2011 version saw the introduction of the integration of the MasterKey Wind Analysis with Masterport Plus. I should say that Masterport Plus has always had the ability to automatically generate its own wind with its own coefficients of pressure, so that's nothing new. However, previously there was the expectation that you would simply specify your own Q value, your wind panel pressure value, for your portal frames. However, what we now have in the 2011 version is full integration with the MasterKey Wind Analysis site data and to automatically generate that Q value for any given site. So over here in the wind and snow, this whole area is quite simple and quite new to the 2011 version. Previously, if I uncheck that box, as I say, this is the type of thing that you would have seen. You would have been entering your Q values, which you may very well have determined from the standalone wind program and then slotted in here. However, now all you have to do is say, no, actually I'd like to use the MasterKey wind loading program, specify my angle to north, specify my wind analysis methodology, and you can see all the time those values changing because the Q values are changing in the background, and of course link through to the wind site program and choose your site, etc. So that's all very simple and straightforward and much more convenient than it perhaps would have been previously for you. Okay, that concludes today's webinar. Thank you very much for your time and attention here today, and we very much look forward to seeing you at our next webinar.